Hello, Professor Sargent here with you again for another Math 101 flipped classroom lesson. This one's on section 4.4. On page 302, we are reminded what a polynomial is and are given several examples of a polynomial. But furthermore, a polynomial is a function if you set y, or f of x as that fancy stand-in for y, then those four arithmetic operations of adding, subtracting, multiplying, and dividing, as long as you're not dividing by zero, those all give you unique results. So when we combine a bunch of those, and by the way, raising to an exponent, we could think of for now as, since these exponents are going to be whole numbers, then we could think of the exponents as telling us to do repeated multiplication. That falls under what I just mentioned then about unique results. For each x, there will be one y. Whatever the highest power of all of those exponents, whatever the highest power is, that is the degree of the polynomial. And then we see several examples of evaluating. So I'm going to do a few of them that are on the assignments. As I get this going, take note that our work on section 4.4 is divided up over 2 days worth of class. So here we are asked to evaluate the function f of x equals 8x plus 9 when x is equal to 8. And according to the order of operations, we would do 8 times 8 first. That's 64. 64 plus 9 is 73. I'm also going to type that into the TI-30 real quick for a double check before I press enter. All right, so 8 times 8 plus 9. And we do get 73. And they agree. Now we're supposed to put in negative 8. That should give us negative 64 plus 9, or negative 55. Checking that. To get a negative, you don't press the minus, you press this negative sign on the lower left. Negative 55. All right. Now, I'm not doing all of these, but there should be one that's going to take a little more work. All right, here we go. We have f of x equals negative x squared plus 3x cubed minus 8. By the way, that could have been written with the 3x cubed at the beginning. But since the highest exponent is 3, that makes this a degree 3 polynomial. We could put 3x cubed minus x squared minus 8. And so we're putting in negative 1 first of all. So 3 times a negative 1. You may need to put parentheses around this. Raise it to the third power. And then press to the right to get out of the exponent. Minus x squared. So that's in parentheses, negative 1 is getting squared. And then minus 8. Before I press enter here, exponents first, negative 1 cubed is going to give us a negative 1, but negative 1 squared is going to give us a positive 1. So then we'll have 3 times negative 1, or negative 3, minus positive 1, which will put us at negative 4. Negative 4 minus 8 is negative 12. So now we have to put 2 in. And with these newer calculators, I can scroll back, press enter to copy and paste. And I'm going to change that negative 1 to a 2. Let's see here. All right. 2. Another 2, wherever x was. 2 cubed is 8, and 2 squared is 4. 3 times 8 is 24. 24 minus 4 is 20. 20 minus 8 is 12. And then putting in 0, we know what happens when we multiply by 0. So similarly, 0 to a power is, since those are whole number powers, or actually counting number powers, then we're going to have 3 times 0 is 0, minus 0, minus 8. So in other words, when you put 0 into a polynomial, you're just going to get that constant term at the end, negative 8. This type of question is one reason we take a look at polynomials. We're told that imports of coffee into a country during the years 1999 to 2010 can be modeled by the polynomial function that is given right here, where x equals 0 is the year 1999, x equals 1 represents the year 2000, and so on. P of x is in millions of pounds of that coffee that's been imported. So for the year 1999, since that's x equals 0, as I said in the previous example, you put 0 into a polynomial, you're just going to get the constant term at the end. And so that's 1.582. And they've already put for us right after that space in millions of pounds. That's interesting. Let's see what happened. I see. They want to the nearest tenth of millions of pounds. So 1.6. See if they agree with that. Okay, they do. So next we're supposed to find out how many pounds in millions of pounds of coffee imports we had. So first of all, since 1999 was year 0, then 6 years later is 2005. I could just count that off, but subtraction should be easier. 1999 is year 0, 2000 is year 1, 2001 is year 2, 2003 is year 4. Lost track. 99, 2000, 2001, 2002, 2003, 2004. Okay, hold on. Okay, so I am correct saying that the year 2005 is corresponding to x equals 6. And what I've done here is wherever I saw x in this polynomial function, I plugged in 6 for x. And I'm going to have to scroll for you to be able to see all of that. So here's the 0.7151 times 6 squared plus 5.884 times 6 plus 1.582. And then remember that they wanted that rounded to the nearest tenth of millions of pounds, so 62.6. And then 5 years after that, that should be where x equals 11. So let me scroll back, press enter to copy and paste. And I'm going to change the 6 to an 11. And I'll have to insert. There we go. So rounding that to the nearest tenth of millions of pounds, 152.8 is what it should be. 152.8. There we go. for the remainder of the assignment, they talk about sums and differences of polynomial functions. And on page 304, we see this. Notice that the domain would be whatever the intersection of the domains of the original two functions are. Intersection means what's in common. Now, the nice thing about working with polynomials for the time being is that all real numbers are the domains of any polynomial. And so what would be in common between two of them? Still all real numbers. What I'm going to do is break down solving this two ways when we see questions involving sums and differences. All right, so I'm going to use the space here so that you can see what I'm saying, what I'm thinking. One option here, oh, by the way, I will then just give the final answer afterwards. Okay, so one thing we could do is break that up. That's supposed to be talking about a new function, f plus g, from the f and g that we start with up here. And then we're supposed to evaluate it at -4. But the definition that was just given is also telling us that that is, on an individual basis, evaluate f of -4 and g of 4, and then add them. So -4 squared is +16, and 16 minus 16 is 0. Whereas putting in -4 for x in g of x, 4 times -4 will give us a -16. So I should be getting an answer of -16. Now here's another way we could come up with that. This is particularly important if you would be working with the sum of these two functions over and over. I could add x squared minus 16, whoops, plus 4x, those two separate functions, come up with a simplified formula for that. Since there are no like terms here, I'm going to put this in descending order, no like terms to combine. And then when I evaluate that at -4, then again, -4 squared is +16. 16 minus 16 is 0. Subtract the last 16, and we get an answer of -16 that way as well. Here they ask for subtraction. Again, I could evaluate on an individual basis. Oh, hold on. Okay, here's one where we're supposed to evaluate. So again, I could evaluate on an individual basis, g at -9 and h at -9, and then do my subtraction. So let's see, g was 3 times x, so 3 times -9. H was x minus 7, so -9 minus 17. Sorry, -9 minus 7. All right, in the first set of parentheses, I get -27. And in the second set, I get -16. So I'm subtracting -16. That's the same as adding -27 plus a +16. My answer should be -11. And that's the only thing that I would include in that space when I finish. Let's see if we get a -11 the other way, where first we come up with a formula. The order of subtraction matters. So our formula would be 3x minus the quantity x minus 7. You'd have to distribute your subtraction, i.e. multiplying by -1. This time we do have to combine like terms. And then we could put in what we had for x into the simplified formula for the difference of those two functions. 2 times -9 is -18. And -18 plus 7 is the -11 that I mentioned earlier. So I'm getting the same thing 2 different ways, either evaluating individually, or if I come up with a formula for the difference g minus h and then evaluate. Again, that is most useful if you would be dealing with that over and over and over again. You're probably saving work if you come up with a single formula and then evaluate. A little bit more to do, just a moment. We want to come up with just formulas. You can tell we just want formulas because of the x's only here. They don't show anything else. And we are given these two functions. We want to find the sum function, and then after that, the difference function. So if I add 4x squared minus 9x squared, I'll get -5x squared. Positive 7x plus 4x will give me plus 11x. And minus 5 plus -16 will give me a -21. And then our difference of those two functions. I'm going to show a little more work here. And again, I will erase afterwards and just give my final answer after that. So the 4x squared plus 7x minus 5, we're subtracting from that all of -9x squared plus 4x minus 16. So you have to remember to distribute that. And that means that we're going to have plus 9x squared minus 4x and plus 16. I'm changing all three signs there to turn the subtraction question into an addition question. Now when I combine the like terms, 4x squared plus 9x squared is 13x squared. 7x minus 4x is a plus 3x. And -5 plus 16 should be getting plus 11. All right. I'm going to double check, see if there's anything else different that I want to cover. Otherwise, this may be it. Yep, that's all I've got for now. Hope this helps, and I'll see you in class.